Okay, we at the last question in this particular function question, the last section, 4.2.6. It is part of the parabola and the line graph. Now remember, we have just found the inverse of the function g of x. So g inverse x we found to be 2x minus 9. Now let's see what they ask us. They say the following. If h of x is that inverse, which, look at this, there's a plus k. So we are transforming the graphs that we have on our diagram. Okay, so we have a new function, h of x. How do we obtain it? It is the inverse function, which is what we found down here, plus k. Okay, now we'll talk about that just now. If that is a tangent to f, now I think, let's read through this first and then we'll go to the sketchboard and the tips. Determine the coordinates of the point of contact between the two functions. Okay, now that's very interesting. Let's just write our function f of x down as well. Okay, f of x is equal to, we've known that now for some time, f of x is equal to a half x plus 5 all squared minus 8. Now that was a parabola. Okay, the inverse of this parabola is something with a gradient of 2 and that cuts the y-axis at minus 9. So I'm just putting that line in anyway. We are after the coordinates of that point where they cross each other. So first of all, remember a tangent. A tangent is a line that touches whatever curve it's related to. Okay. To find a tangent, there's some ways that we can find it that is quite quick, and that's using the derivative, the notion of our derivative. Well, what do we have? First of all, we have the gradient of that tangent. It's the gradient they're telling us. It's the gradient of the inverse function. But now look at this. Where the inverse function is, we have a plus k. So this function is going to either go up k units or it's going to come down k units, the original inverse, which might have just been over there. Okay, it might have been down here. I don't have a clue where it was. But we need to find this value of k that will make the inverse touch the parabola. So the key thing they told us is that we have the gradient of this tangent. So if you have the gradient of the tangent, let's write this in your tips column. The gradient of the tangent is the derivative of the function at a particular point. Okay, and at this, that is exactly what we are looking for. Determine the coordinates of the point of contact. Okay, so that's not a problem. We need to find the derivative and put it equal to the gradient. And once we've got that, that will give us an x value. And for the y value of that point, we need to go to the original function and we need to put whatever the x value was for the first result. Okay, I hope we know what to do, so let us see how we are going to go about this. Well, for me to be able to differentiate the f of x, I quickly need to distribute this. Okay, so we're going to get f of x is equal to a half. We have x squared plus 10x plus 25 minus that 8. Okay, and that gives us a half x squared plus a half of 10 is 5x, and here you have 12.5 minus 8, which leaves you with 4.5. So this is positive 4,5. Yeah, let's leave it as that. Now we know what? We know the derivative of this function is equal to 2 because it is the same as the gradient for the tangent. Okay? So if I differentiate this, let's just put this down. MT, the gradient of the tangent, is given as 2. So if we differentiate, we get x. The 2 comes down, takes care of the half, plus 5, and that is equal to 2. So then, this indeed, what we've got here, is the x value where they will touch. Okay, so we can say the x coordinate where they will touch is this 2 minus 5, and that gives me a minus 3. The x value where they touch each other. Now all I need to do is put that into, remember I'm looking for the point of contact between these two functions. It has moved. So this here is a new y-intercept for that function. So if I now go back and I find the y value of the point, well, I can pretty much put it anywhere I want to put it. But it goes straight into, I am going to put it into the parabola. So the f of negative 3, because that point lies on the parabola. So I don't need to solve for x, or for k rather. If I do not put it in the parabola, then unfortunately I've got to go and find the k value. So f of minus 3 is a half, negative 3 plus 5 all squared minus 8. That gives me a half. This leaves me with 2 squared, which is 4, minus 8. A half times 4 is 2 minus 8, and that leaves me with minus 6. So the point of contact between the two curves, the xt and the yt, x coordinate for tangency, y coordinate for tangency, is the point minus 3 and minus 6. And there we've answered the question.